Okay, let's talk about that curb pressure, tire curb pressure again. Again, guys, this is a result of a motor vehicle test. So this is the real deal. This is a calibrated machine that I put the vehicle on. This shows that when I apply brakes at approximately, pulling into a parking lot speed, that the front wheels put out a force of 3,664 pounds on the right wheel only. Correction, that's across both of them. That's across both of them. Wait a minute, I'm trying to focus. There we go. And the rear wheels put out 3,774, and this shows where that forces were not equal across the entire tire, but they calculate that it's more near the rear of the tire. This will be like a cutaway view of the tire, and the braking force here is on the back side. Isn't that interesting? You think it would be on the front side of the tire, but I want you to take notice that it's the rear part of the tire that's taking that force. They're skidding. If you were to slam on brakes and you were skidding, you would lose tire, not in the plowing front part, but the rear part of the braking system. That's how it's explained to me how their machine interprets the calculations. I did ask them. I asked another person there, and they said they didn't know. So I did ask twice to try to do some verification. Here's the balance of that. So it's 9 and 6 is 3. That didn't quite work out. 9 and 4. Yeah, I told you I got a little dyslexia thing. I see the numbers correctly. I just pronounce them wrong, especially these live videos. So you got to guys bear with me when I say things like 2-6, and I really mean the 1-6, because in my brain I know I got 2-6 and 1-6 I'm dealing with. So I might have came up with the right calculation, but then just said the other number. I said might have. Who the hell knows? That's going back on that one. So some things are not breadcrumbs, like me saying that one. That's just a mistake. All right. So here's the brake force here, 1749, and over here there's an additional 155 pounds of force over here, rather, compared to the one to the left. At the rear, the difference is, wow, that's 2,000. It's about 130 pounds. More to the right again. The force is more to the right than left. So that's just braking. And that's at that slow pulling in the garage braking deal. And there's the total front axle there. It's 33, the rear axle, and the vehicle weight weighs 7,000 pounds. So isn't that nice? You guys talked about the truck. Quite a few you said the vehicle's about 7,000 pound vehicle. Well, there's your loading. What a 7,000 pound vehicle could do at just parking lot speed, if you will. And believe me, I try not to, when they try to get you to go fast, I try not to go fast through there. But I was able to get the supervisor to let me get copies of the results. They don't do that. They don't do that typically. Let me just, help you with that. So this is the 7,000 pound vehicle. That's the engine weight up front there that's doing all that extra loading. And I was going forward. As you can see, the arrows directions. I think I would love to go back there. Isn't that great? Go back to motor vehicle and start say, look, let me reverse and give me a different loading. Give me a chart. Slip them a little bit of change, a tip or something. No, I can't do that. They're state employees. Remember, there's the camera. Let me go to the next content. Hold on. So I'm circling back around, having a little fun with Carolina baby. Carol Ann baby. All right, so some of you guys know now what a BMA is, and an MBA is it's a real thing also. It is a precast concrete member. We went over the NIST thing over this one to show it to you. I believe this was my NIST one. Maybe it was somewhere else. But I want to show you that I use them interchangeably. I would say incorrectly because this says BMA. But the intent is there. I want to take time to show you the overlapping. Quite a few people say you can't do that reinforcement across the control joint and make the rebar go through. This is in 2 times 2 pieces, but that's a construction joint there. This one is not reflective as much. This is different. This is sacrificial. This will stay. Now let me get you another one. So this is a real one. This is one, a smaller one. What a smaller one looks like. these hold up these slots hold it up where you profile it wherever you want it to be. But that's the keyway. Looks like that. That's the male side. It creates the female side. So the male side would be on this side if you were going to do it. But normally you pour that side and pour into it, because it's going to give you a lot. You can segregate into this better. When you do it that way, you now can't segregate underneath and behind. So the image I showed you was someone who did it this way, and it's not as effective. It's not as effective keyway as doing it this side first, because now you can get consolidation of material in and work your pile your way up. This one, you've got a little bit of back bevel that you're going to have to press a lot of mortar into kind of differently. I prefer to see the keyways done in this capacity, and shove your concrete in, and then come back, and when you're filling the other side, be very mindful of the joint. So that's what they look like. They come in these lamps. You butt them up together. Well, what are these? This is for electricity. So when you're running electricity, you're able to put your conduit in it, and of course you want conduit approximately every 6 inches of electricity. So the electricity. Wait a minute, electricity. Oh, that's a lot of electricity, isn't it? Oh, wait a minute. Am I doing one of my pull your leg things again? Apparently I am. So you put your rebar here where you want it, your rebar here, and these punch outs take rebar. Rebar would be in the middle of the joint there. So that's what the punch out looks like to get you that rebar in the middle. So people who tell you that they can't figure out, that would be a complicated joint. Back in the day we made these out of wood, same thing. We would just drill it and slide the rebar in. Now you've got these beautiful punch outs. You put your rebar in there, you center it, and very minimal paste would come out of it around this edge here. You still clean it up though as you're finishing the concrete. You wouldn't leave a nasty bit of paste here. This would be cleaned up, detailed. I just wanted to show you that. All right, let's move it. So as you can see in this joint here, they didn't put any rebar through there. I don't know what this material is. It presents kind of differently. That's clearly a transition. Now, I'm going from there. I guess in this video I'll give you a hint towards where we will go. You notice the rebar direction will tell us our collapse. At that floor level, at each floor level will tell the direction of the flooring as it collapsed. At one point we're going to see the rebar turn. There's a column there about here inside this wall. There is a pulling moment, a screw maybe it was in there and the frame, and it pulled it out, but that's in the same direction if you consider this part, the top part, in line with this rebar. Don't worry about the bottom, that's just where it pulled. It's in line with that rebar reinforcement. Just a slight bit of an angle, but that slight bit of an angle tells you what the front of this facade was doing at that level. This will talk to us. This appears to be anchored down what? What does that look like? The inside of it presents as an inside of a weird stovetop, perhaps. An odd stovetop, or is this a desk with a flip-up opening? There's a desk there, so there's no stove in here. But I'm showing you can start seeing ghosts. It's a bed frame. This is a bed frame, guys. See the bed frame? And we can start seeing whatever I start projecting into your mind. We've got to be careful with that. We've got to be careful. That becomes a bias when we start listening to a lot of other data. That's why I don't go to those other channels and things like that, unless you guys direct me there for certain reasons. Then I'll go look and go, okay, well, yes or nay. And then I just, I look at it differently. But let's go from there. I think we went over this already, how the jacuzzi's was at it, but it's got its own pier base, distribute the load for the pier of the pool, and it worked pretty damn well, didn't it? During this collapse, it stayed status quo. And then here's our head, is what's so critical there. I'm sorry, I just saw a message that was kind of weird that they knew something already. They posted something that I posted. They replied to that I only just posted it, but I thought it was in a private, and someone just replied to it. So it looks like I made a mistake and put one of my posts public on one of my forums. So look, there's your mostly what's left is that overlay, and the deck is gone. The overlay material. I did not find that sand as it presents. That's hanging piece of rebar, holding on to it. Obviously, it's an interesting little piece on its own. Here's our columns, our back wall. Come on, camera. Our back wall. The reinforcement is vertical also and horizontal, as per the drawings. Remember, this wall came down at one point. This is a rebuild. This rebuild was expensive, and they put these little dividing buttresses, if you will, every so many feet. Obviously, it got engulfed down at this section. And remember this image, this is where we see him removing some, quotations, evidence with the excavator just rocking it back and forth. And apparently evidence can be beat up like that and you can still get evidence out of it. Well, I guess you can get evidence of what happens when you rock a member back and forth instead of cutting it. They have a chainsaw they can cut through this, right? They got blades that will cut through this one and done all the way through. You know, so I find it nasty that they didn't do that. And they cut many a rebar here with those stubs you see sticking out. So let's take the time to look at the one to the far right of the deck. This is the camera light right here. Tom, I sent you this last night. There's the different colors, the transition, and that's the camera. Okay, so that's exactly where that is. And so you can figure out where the base is, right below this block. Below that is where they put the new pots in '96. They appear to load them right over top of piers. Right, so camera light, and here we go. So I call them camera light. And like I said, my brain gets a little twisted, you know. So look, camera light. I believe it's this one, or is it this one? I believe I get confused on these two pins. So either way, they're sitting just thereabouts on top of BMA. Wait a minute, if that's sitting on a BMA, and that's sitting on a well, we got to have this one. Or we got to have this one out here, way out here. But if this one is punching up, that means we have a failed BMA right here, as you saw the punching up. And then camera. Let me get you the camera light, the painted one. There's only, by luck, there's only, appear presents as one being painted. Oh, I didn't know the recording was on. I apologize. I thought I paused it. So in this recording, we have what appears to be one light, one camera way down the far end here. but they're going to add more in this further part of the recording. I'll see if I can edit this out, but not this cycle. And this image are the palm trees that Jaffoff, whatever his name is, says that you need a giant lift to remove these small palm trees. You can see how small they are. They're inside the boxes. Now, this is interesting because these were called for initially, and yet the boxes were called for in '96, the planter boxes. Or I could be getting even though I looked at the planter box permit, there's the pole. The small planter box permit appears to be out there at the outer wall. The ones I've showed in another photograph where they're leaning a little bit. But they were also after that hurricane, so it's kind of weird. Before the hurricane. So look, there's the pole. You see how close it is to the box. It is not connected over here. That was just one of my optical illusions having a little fun. But it is connected here. But I think I corrected it in the comments real quick so you guys didn't get too far in it. There's that box that's turned on a 45, if you will, in. So what do we see missing? These are gone. This is gone. I can make my way up to the light and show you what's not gone. Give me a minute. So this is noteworthy. Here's where the planter boxes were. You can see that this is beveled back away from the structure. That would put it thereupon where the steel is also bitched about in a couple of video reporters' content. There's somebody swimming. Anyway, then it turns and it levels off a bit. And then it does that dive again. Visually, a dive back down again. Visually, because it could be optical. There's that pole again. And yet there's my camera pole right there. With the colored version of it. And there's the other one that's painted, but it's way outside the structure. But this is my colored pole that's colored the same as the base. And again, I can do better than that. There's a picture of it very clear. This gets you alignment for that pole. You can see it's just thereabouts before it of the column in the background. Try to get you a different pointer besides my paw. Hold on. I don't identify as an animal that much, but I guess we are. Okay, welcome to the painted pole. So that's the one with the column sticking through. All right, column sticking through. There's the next box next to it. So this is the one where we see it's sticking through, and there's the pole with the electrical outlet here, and the light. I keep saying light, camera pole, and there is that planter box. Those are the planter boxes that made their way out further into the deck, turned in a little bit of an angle. These appear to represent the same chairs that have been there for some time. There's another one over here that's also painted, but it's off the end of the building, so we can discount that for now. Here is, in fact, I think it's past the, it's past that opening where you walk through. I think that's opening the gate, and it would be to the right. This is the one that is by the planter box. Take note of the yellow, see? I really do have an issue with that. But I learned to live with it and just explain whatever. Whatever color this is. Sandusky Airman. Yeah, okay. So whatever. So this brings us back to this light. There it is there. There's right there is the electrical box to it. So this gives you your elevation. And that gives you that. So we have our deck right about here on the debris. So that's that. Remember that's your electrical outlet right there in the middle. Right in the middle of the photograph. That's an outlet box. I'll shrink it down and show it to you again. Right. Come on, mouse. Right there. That outlet box presents as right in the middle. Come on, mouse. Ah, shit. Opened it up. Didn't mean to do that. So go over one tab. Right there. Okay. So now I'm only going to data stack so much for you in this video, and we're going to slice them up, dice it up. There, the box still presents us in front of us. The camera is an odd duck. did it take a rotation, or did it get sheared off, or is it the lens get broken off and there's a small peephole lens there? I don't know. This appears to present as the Jimmy Jam. Now we're going to go back to the entrance ramp. I wanted to find this image also. You know, I double dip. This is what block looked like with the symmetrical holes. They have this web in the middle, and then this larger one. That ramp image I showed you in the previous video with those holes are not block. I said nice try to one of my nice followers, but I said no. I'm sorry for being abrupt and aggressive like that. I just wanted to move it off there real fast. That it's not block we're looking at, because you would also have this gap here, the web gapping. Now some block they could use, but they obviously this one doesn't do it. Where there's a single divider and then web and web, but they're huge. They represent as huge and not so cylindrical shaped, because they're not. They're more rectangle. Obviously you can see where this came from over here. This punched through, and when it ripped off, I'm having fun again, so bear with me. When it ripped off, the gravitational spinning of the earth spun the box. Or when it ripped off, did it shear off, and as it was still holding on to the floor is going down, rotated this box to its final position, and there's your last contact point. Appears to represent your last contact point. So if you could reverse it, you would say, this is the last one piece that went down, and so you would reverse it, putting it back, pushing the deck back up, and imagine it rotating back into place. So here's our last point where the deck went down. We'll remove vibration that caused the rotation. We're just going to say that it was the rotational forces that did it. And we could try to verify that with some tearing action of the materials, ripping of it. The face of this being over here, I would... I'm not going to go down that hole right now, because this thing could be okay, so there's a short dimension. Well, there's a short dimension, a long dimension facing us. It was long dimension facing us, short dimension that way. So in that case, we would have either this is the face that faced us or the other side. I'm going to theorize this was our faced side. It was facing us, and we can get it back on there. Why? Because if this was the back side was our face side, look how high that would be above those blocks. So this corner, I believe, belongs right about here on this corner, and so the rotation, this would be facing the pool side. So you can imagine as it pulled away, it was trying to hold on, and that caused the rotation as it sheared away from the block. Still holding on, one section here, one section there, and that gave the rotation. And in the back side, that appears to be the full length, the full height right here. So it's once it rotated off, it punched through, and this could just be the weight of the box that dropped down to here, sliding over the head like a condom. Yep, I said it. So circling back around, we now have the material of the head here. This material of the head, clearly if you were to lift this deck up, this crosses over into this side, I believe. So that acted like a little puncture protection, if you will, and it just broke it off in this capacity here. So if I can move this column out of the way, if I imagine I move this column, where's this piece fall down to? I believe this piece here falls over to here. So this puncturing of the deck, this is a cover, so we can just remove it out of our formula. Now look at the deck itself. And then we look at the ears. We see they were uniform break. They're just about all at the same elevation, all about the same bending moment, right? So they're all about the same at the top of the heads. So this was more just like a pull down like that. No drape effect at that point. Let's go from there. So here's our light pole and our planer box. From here to here is approximately 7 feet. We see the face of our planer box. We even see the shrubbery. So internal, or is it external? 7 feet. That one we can look at together. Focusing, sorry. Next to it is a step down, another planter box. This is that planter box along the front. This is where the sausage put a pole down across here, almost coming to here. If we know the elevation height of this pole by human photo, if you got a human there, that would be great. We also have a trash can. It's very critical, that trash can also. It's weird how people are creatures of a habit. They'll keep putting things back in the same place. So that trash can will also tell us, trying to focus here. Great, come on, baby. Okay, there we go. So that trash can will give us data. Now find the white boxes. Find this little, yes, screw me as we say it. It's hunting because it's the contrast is, it needs the pixels have to do the focusing by contrast. So they need to find that contrast, and they're finding the pixels what are same. So that's when you know it's going to hunt, because it doesn't see a contrast difference, so it can't lock in one pixel to the next. There we go. So so that's why I just moved the focus over to the grass. That's all I did in the imagery and the screen. So our trash can has a fracture in the block wall. The block wall, we can see down the block wall at that point, and this is shifted over. So this tells you that the sausage came down, smashed this, and moved this over the entire, let's call it a beam, moved it over, and it took out the pole. Pole came down this direction. So we know which angle that is. Now this is the pot here. Is it this one or is it this one? Very critical. Is it this one? Take a note of it. N-O-T, note. I like playing, guys. Come on. Okay, so this is the one forward of it, right? That's forward of it. And there's a shrubbery down low. That's forward. This is the forward one, not to be confused with this one. So 1, 2, forward and back. Small, tight shrubs that will push out. Or fake shrubs here maybe, and real shrubs there. So now, here are your shrubs. First box. I think the second box is under here. Shrub still, shrub greenery, fake shrubs here. Shrub greenery, fake shrubs here. Right about here is that pole. Pole's about here. All right. Hit my PayPal account to the engineer. Look, under here, this is a sausage underneath of this. Explain how that got there. So now, I do have an image of when they purchased their room 111, but it's on the listings. But let's just go with this one because it's more open and gets you visual. Here's a refrigerator here. Now I'm going to talk about that damn appliance that everyone keeps saying it's a dryer, and we're going to discuss that dryer in this video. Washing machine. It's a dryer. What the hell you guys call it? This is what punk shearing protection looks like. Some of this, and it's the critical shear you're tying into the tributary zone. This doubles as critical shear material, but also tying into the tributary zone further out. Look how nice it looks. Look at that beautiful steel. How nice they did it. Look how nice they did that. Okay, so any contractor should be pointing out, are you shitting me? Look at the cover there around that steel. There's going to be 3/4 inch wrapping that steel, but there's not going to be any cover. So this is actually a defective setup. But remember, I showed steel work pretty awesomely even when you don't cover it fully. Here's our head again. So what I'm doing in the videos now is I'm going over with important points again and again. I'll do them a few times before we step to the next step. So here's our head and our construction joint. Construction joint shaped like what I showed you. There's some rebar at the very bottom. It still worked. It's at the very bottom with some paste on it. You know, it's like a 3/4 inch, coverage and paste. And I showed you how I can load a machine and get away with it. And then we have this guy here. Look. Look. So the this head worked. Remember I showed you with a piece of paper, one single piece of paper over that column display I had, and then I did 11 sheets, and I go through it, then I turned it to 24, and it was no good, no go, no punch shearing. This is why it matters concrete above. Now, I heard there was a lot of sand between these two layers. Well, again, the person that put down this should have waterproofed there before they put down their, that should have been done before they put down the deck, right? So who authorized that? Who permitted it? And why wasn't the deck waterproof? Did they not know it was a water issue then? Or was there no water issue then? So I talk about plywood, stockpiling materials, and we have stockpiled plywood on this deck. A lot, it's distributed, but nevertheless, it's still stockpiled. It needs to be located at the point where it will not cause deflection in the deck or deviation in the deck. Bruce. Good boy. Thank you. There we go. All right, so back to this. So let's resume at the group meeting here, as I like to call them, circle jerk. On this one, who's in charge here? I don't know. They don't know. The posture said they don't know. They're just going to guess at it. Zooming in. What do we have here? We have the critical shear area with the break off, and I can't see they moved it, so I can't say this steel was in this configuration, but we can say that this column, how it sheared off, is similar to how it sheared off at the parking garage area. We can also see that it's near the top. The reinforcement's near the top here, which is about right, but you also want some at the bottom also. You don't want to just put one piece in there like that. Maybe that's a piece there. But they kind of shy on it, but this building stood for 40 years. There's a few people asked me, well, there's not enough steel. Look, it's 40 years, plenty enough steel. We see what happened. Unless you kill off the witnesses, the deck failed, causing this whole collapse to progressively collapse. Building didn't fail. The deck did. You see the one piece of steel near the top? This allows for the dead loads of the structure to just peel that off, like I showed you in the previous video, where the parking garage, where it just splits the top off. This also has to take a dead load, not just hold it in deflection as it's trying to do it. It's a little bit of paste over there stressing that top. It didn't fail in that capacity, though. It failed during its failure mode, real easy like that. But not as a result of. It's the deck that took this down. So, looking at the existence of this slope could be a result why we have a break that presents itself here, because these aren't going to react the same, considering that they're on different elevations. For whatever reason, run water off. Maybe they got a hole over here and they run water back to the building and off like a gutter. But that's going to create, when that goes down, a reaction, a moment right there. And I think that can explain our crack out here more so than if rebar was missing. If it was missing, then it would come out and fold over. But this goes up, so it seems like it's anchored at that point. Again, I'm giving you the data over again to help you see where we're going to go with this. Oh, I'm going to talk about the planks. Let's don't forget that. But the tributary areas here are so friggin' crazy that you get this progressive collapse so easily. It can't, because when one section collapses, it becomes a new loaded tributary area. It has to stop it from collapsing further. The critical shear areas around the columns have to stop it. That's a fist. They have to stop it. But they load those critical shear areas during this collapse, and those critical shear areas said, well, they go like this, They slip right over it. They let the deck slip right over it. Hey, look, it's how you guys remember it. Look, hey, we got to know that sex sells, man. Sex helps you remember it. It slips over the column. Over the column. Here's the column. It slips over the column. Now, if she had the door closed, it wouldn't be a slip over. It would just hold it and maybe break half the side of the column off. But she beautifully so. If you look at all that rebar, just says it transfers the load pretty much onto the other side of it instantly, and they come down together. Just as slick as can be. Real horny like. These are some old drawings that I don't know what they're dated, but this is what the planter boxes look like. So we're there. Now we add that light. We add the extra planter boxes, but these dimensions appear to be the same. 7 foot. That's 7 foot. The planter box additions are here across the face, and then another one here on top of a beam perhaps. This is where our load path failure happens from, I believe, defective breaking this down. Well, this is apartment C. It's breaking down either M or and still I'm going to tell you, or is this in LM in or in? As this one goes, it pulls on that one. That creates an unsupported span between the two of them on the upper floors, trying to create a larger tributary area with the supports of the flooring. They can't do it, and so boom, butterfly down. I showed that in the other video where I show the end of the structure fractured like this to show that it can behave in that way on this structure. As you look here, there's a bathtub over here, and our collapse is here. Do we see a bathtub in there? Not necessarily, but here's our kitchen layout, typical kitchen layout for that C. Remember, she might have had a remodel, but I think the kitchens will still stay the same, so will the bathtubs. If anything, I picture that she would add right close to the sink a washing machine here, but look what's in front of the washing machine. We have all these appliances. So I have my brake at here and here. So the washing machine would have tumbled over and fell down as this broke. If the washing machine's there, tumbled over and landed on the deck below. That's how I get the washing machine to fall over to here. Now, there is a building there is a room next door. This is whatever this is. So when that collapses, I say we get the secondary rolling over and hang time and falling. I could get this collapsing, and then I could have this wall falling over, collapsing, the wall. But it's just a non-structural wall, so it still could be supported there. This is just a block wall, non-structural. Our structural wall gets out to here. So this is non-structural, so we could get the block wall falling. Do we see that debris there? I don't see those ghosts. This is a bedroom, so I don't see that either. I don't see a lot of you guys see couches and beds. I wish you guys could send me that image. I couldn't find couches in bed. What appears to me as a pad, but it has a fracture in the middle, which is more indicating that it took to break in the middle like that. That we're looking from this direction down, the arrow down. It appears to be broken in the middle, which means to me it would imply more that the pad flipped the sideways first, fractured, and then the other part of it pulled down and fractured, which is weird because I don't see the hang time. I don't see it hanging up from rebar. It's flat. This is a huge section of flatness, if you will, 20 feet, using the word flatness. Okay. Our car parking is here, right? Light pole is right about there. Camera pole. Car parking. Planter boxes are there. So I'm going over to the model, and I put our planter boxes in, and I put what I show as a light pole here, going over to that one. Not so overlapping like that with the sausage that's underneath that pot. There's the pot that stays in place. These drop down. This will tell you whether this is a flat, if you look at it in different images, is this flat or is this tilted down? Well, you look at the deck and you look at the bottom of that metal, and they present as flat. They don't present as a crown below the deck. The pipe was only impacted one time on the end. It rolled over, it hit the deck, slapped on the deck. It presents as a tube, flat. And so I think we're flat from here to here is what that gives me data on. I don't see the deck buckled under here. Look, translating that to over there, it presents as a level plot there in front of the structure. So I have now data that says that this is sort of dropped together, this section over here, that they stayed together. We don't see rebar, we don't see fractures. We don't get fractures until here, and then that fracture I show you goes like that. That presents as a two breaks. That could be because of this structure here, when it collapsed, caused that impact, and that fracture is actually coming from that direction over to here where it stops, over to where it presents to stop, right about the flower boxes. I would present to show you that that these act as an isolation break with the loading of products and materials. I think that sort of did it already. If this is the impact that hit it there, and then you show a crack, and all of a sudden the crack just stops right about there, about the planters. That's what actually I was trying to show you, that what I could reproduce, is that it's odd that way. Cracks will run up to something, and the energy will somehow get absorbed into the structure that it's running up against. Specifically, if you ever form forms, you put a little hammer behind it, and you pound with another hammer to set a form, and it will stay. The form will stay where it is, and while you're tapping on it. But if you just try to drive a hammer on this side, you're going to knock your forms over. But just backing it with that, holding that hammer there and tapping, it just the hammer absorbs the energy, and you just keep moving the hammer back, and it's amazing. It's a pretty feat. It looks like a magic act that's happening, but it's absorbing the energy into the hammer and allowing the nail to penetrate. So this is our hammer. Our forces come over. This is that backing hammer. So now let's jump into the flower box. Let's look at this right here tilting down, because I'm not gonna make this video. This video is 43 minutes or so right now, so I'm gonna have to keep these under that timeline. We get this collapsing first. If you do that, you get this incline like this. Here's your refrigerator. So that doesn't work, does it? We don't see it like that, and then this slipped underneath of it. It would be like that, wouldn't it? We would see a refrigerator in front. Instead, you see a deck down, and then you see this material on top of it. Interesting, it's like cardboard. That perforation is like cardboard profiling almost. Not quite there. But we see that. So we get this deck collapse internal from the garage area. So from the view down, we get the collapse. And then we get materials on top of it. So we get materials on top of it secondarily. Or did this opening here break free? It's just pulled away, just that snug, that little bit of pulling. Let's move my cars. I'm going to talk to you about that in a minute too. And another video about cars. They're on my deck that gets pulled. As we pull on tug on the deck just a little bit, right? You see it wobble. As we pull on that just a little bit with the puncturing, it didn't take much to pull it away. We know that it didn't take much to pull it away over here. It just dropped straight down. It broke free. The weight of it, as you guys call that gravity, I just say it just meant equilibrium at that point. No, the forces now matched up. It was a dead weight on this side at that point. It was actually stopping it from pulling that way even further, because now it said, whoa, I'm totally dead weight now. So that met equilibrium and then punched down. It was attempting to pull all the way across over to here. But again, because it met that open joint, once it freed up, this side became a counterforce for the pulling forces on that side as it came down. That counterforce gave it equilibrium and came down. I tell you, everything can be described with equilibrium, right? So, and not the engineering formula, but equilibrium as I stated, just equilibrium. Finding equilibrium. A boat displaces more water than it weighs. That's just finding equilibrium. It's not gravity. Gravity has never been proven. And if that triggers you, well, just prove gravity to me. Just prove it to me, and I'll move off my equilibrium. Okay, and I know there are gravity formulas. I think that's ridiculous. Even the guy that invented gravity said he couldn't prove it. So if he couldn't prove it, He's the inventor of it. Why Newton? So why do you guys think you can prove it? I think if he understood equilibrium better, then he would have said, it's just equilibrium going on here. So we have a deck on the floor ground. We also have what presents as two decks on the ground. It looks sort of like that. And then the guy's on there. I swear I see two layers. I swear I see two layers. So, I'll put us back to the boom. That's the impact. Drop down. It shears away from the wall here, which is shearing away from this column here. Shearing away as it impacts. Slides down the pole, perhaps, maybe. Drops. But it still has so much. Well, it's got to be closer then. So it's going to be closer to throw it at equilibrium. And this will be a smaller piece, so I actually got this backwards. So let's do it this way. And I don't know how many cycles this thing has in it before it breaks. So let's do it this way. So the larger piece falls down. Boom. Well, it's got to fall closer then. Swings down. Swings down. So I would need to know 13.4, 20 feet where the impact would be. That would give me my impact. Slides down, perhaps hitting the column. But then I believe this folded over, and that's what we see there. Now, what do we get here? This is a strange duck. That's a strange duck indeed, along with the other materials. But as we look into it further, and I use my software, it appears I'm looking at reinforcement. Reinforcement that might have been out of here, sticking out ×3, and that might be into one of the BMHs or BMAs coming out that we might be looking from the garage. Remember, she's at 10. The street level's at 1010 over there. This deck is at 1110. Okay, this deck is at 1110. She's at 1010. There's only a difference of see 1110 from street level, so she could almost see in there. She can't see past this BMA. She's standing up, looking down, so she can't see past the BMA, and she can only see down. Now, you guys say it's the flower pot. And so these are accounted for. Accounted for. So this one's longer, and that one's square shaped, right? So that would mean it would drop down and left the BMA in place. I mean the slab drop in place, part of the slab drop. And I talked about that. Did they put a construction joint across here? I don't know. When they did the slab drop, when they made that slab drop detail, that would give us a drop on this side, and it would also give you your box, except for the elevation that this dropped down. We see the elevations there, and before it got crushed, let's say that you would see that this is still flat. This is still flat. So she would have filmed, and we would be seeing the back of this box here in the image, and the back of this box, and then the entire porch. Let's keep in mind that porch on this one, on this side, that porch is much higher. Where everyone's claiming they can see possibly the flower pots, they're 12 foot 9 inches. Remember, this is 1110 per the deck being equal with the pool parking garage. It's 1110. So it's a foot elevation change going up. And so that would be probably a solid pour concrete. We'd be looking at a chunk of solid concrete. Now, it's sitting on top of a BMH, right? And if I can move this one out of the way, you see there's the other BMH. I just don't have that punching through at this time. It did take a moment to move these guys, move this one. So it moved with the deck. It's mounted on the deck. It moved with the deck. This, I believe, if we can now start triangulating that pole, get this one closer to the pole, we can now start seeing the shift of the deck come forward closer to the pole. That's why I went all around this video just to tell you we need to know the length of the pole. The pole is almost touching this box. In reality, if I bent that pole before the collapse, how far would it be from this box? Scale that, and now we'll know the relationship to this box and that pole, which way the tugging took place, if you will, before the failure. We have, I'm sorry, the box is here. The box is back here, the one I'm referring to. And so it would be, I think it's this way. Because there is one that's further, hell if I can recall. I gotta look at it again. It's brain freezing. So there's an extra box added. Right, I said the green one, right. So this is the one there. So the pole is here. So we would triangulate between this pin, which is a column, that pole, and the other box. There are drawings from 1996 that show where they're supposed to be located. So we can now start triangulating these measurements and figure out the tugging action, which tugging action took place. We will not move this pole, the box here though, because it doesn't appear to present as a. It just jacked it off, right off the box, and then but this one is an interesting ducky. I ended the video with that, just enough data to make you have to watch this shit twice, probably, right? I apologize for that. I guess I won't end the video. I'll give you what I'm working on. How did they make this? This is critical. How they made this slab drop. Did they pour up to here, bulkhead it, allow the rebar to run through, and then pour this as a monolithic pour, part of the deck and part of this? That would create a slip joint right here where the rebar would only have so much dimensions, 12 inches max, right? And it didn't go 12 inches. The pullout would be right here. As you can see, this rebar reinforcement is 12 inches. We're only about 6 inches into it. It would have an easier pullout. Of course, it's got to get past this little bit of rebar here that's acting, would try to resist, but it's staying inside this part of the drop slab. This rebar is. So it just has to pull it. It would have a little bit of strain as it try to went across there. But it's at the bottom of it anyway. They're like married to it together. So that would be a very easy, a more easy pull. If they're married fully, engulfed fully, which they don't quite represent 0 inches. They don't represent that detail here. Then this extends out to here, which then extends to here, because as you pull on this one, you're pulling on this rebar if the pace is holding, and you're creating a torque action like that from there. So that would push into that area over here, not pull away. That would push into our parking garage area 20, compressing it. That would pushing in. But if the deck if there was rebar reinforcement here, this is all it would have to knock off. This part here, the lower part, if we're going to take it as a load, as a drape going, then it hinges this way. It spalls this bit of concrete out, and this little bit of engagement here now gets lost. It spalls it out, and then it drops down the few feet, leaving this part to hold up the structure. This part of the slab drop to hold the structure up, and that would be acting as a beam capacity across from here to here. As a beam capacity from here to here, we see again the planter box here, so I don't have that happening. So planter box stays in place. That drop slab gets pulled away from here. So remember, we see 7 feet here, assuming it's in plane. We can then now you look at each one of the columns up here, and you want to see if the deck has compressed it, pushed on it, compressed the materials, crumbled them up, stockpiled them, snowplowed them backwards here. That would show that it came forward a little bit. How much? We only need a little bit of stockpiling of materials coming forward here against this column to separate here. We don't need much. It's only a little bit of engagement to then weaken this structure to allow this to drop down on its own. That leaves the beam capacity. The beam is now is loaded with, specifically the beam is really loaded right here. right? So so then it fails, causing a rotation in the beam. This beam, rotation in the beam, right at that location. Again, we're back to M, and also N, causing them to be stressed and drop to some degree. I mean, literal degrees. That changes the whole format of the whole profile of all the decks above them, or maybe not initially, but then the strain, they can't take it, because remember, tributary area is created at that point. It can't take it, and they I'm going to mess up my drawing here. So the tributary area is created, and so here's a column, and this column is no longer touching, as I showed in the previous video. This one wouldn't be touching, and so it's just not touching on that beam any longer, because the beam went down, but you've got all these floors above loading on that column, but they're trying to make this unsupported span is here to here. It becomes this because this is now 0, right? It's separated. So that's 0. It's separated. This is sitting on top of the drop. This is sitting on top of. Should have did one of those moves like that, right? So anyway, this is sitting on top of that beam. So these slabs, you know, they hold up the best they can. The stresses are too much in them, and they do that. And as they're doing that, they pull this one comes down more, because this one is more engaged with the one to the left of it, so it's stronger, and that would be L. And then to the left of that one would be it gets even stronger in forces, because we're making it back to our wall at that point, and that would be R. So these slabs are able to resist longer. But so our failure is here on M and N. I believe M was our real fracture point, and then N gets pulled over into this supported span thing, as it makes that butterfly effect. That once it's able to start it with those two, say the two floors right here, crippling effect, then it's all going to come that way. They're all going to go that way. They're not going to pick a new moment to work on. This is the next strongest one, the next strongest one, and these two acted the same at one point, and I'll show you in the video the collapse. Okay, so that's how I'm explaining this to you. Our cars go back. I have something to talk to you about cars in another video. Pool deck 1110, right? Let's look going over this again. There's our fracture, so we got to add our fracture. So now we start compounding our data. There's our fracture. So we'll call it fracture. And fracture goes over that direction, and deck. Trash can. Trash can's back here. Trash can exposes block walls that are open. So this was shifted over. I believe when that came down, it might have bounced that like that. See how I turned it in a little bit? Alright, so and then slid it over a little bit, and then we see the exposed block. So it's probably more like that, if you will. Just I should have moved the fracture up a little bit, or made my planter box longer. Just take some liberty with me with that. All right, so I showed you how to triangulate now and everything else. I am, you know, trying to explain every detail I can. This monster there is a monster to try to explain, but we also have that weird anomaly where I put the I pixelate, and I get that weird three-piece rebar, presents as rebar coming out. As she looks down the driveway, it would be to the right, so it would probably be this one, which is our L with the reinforcement sticking out of it. As far as I know, that could even be all further down in the parking garage, where her view might have clipped part of this BMH. And remember, the BMH is at the deck level. So that could be the failure of this BMA rather. That pulled away from the integral part of where it was connected here, and that gives us the view line, sight line of this. So that would give us a failed BMA here with the tugging, or maybe a rotation, a falling down. That would give us that. And that could be, you know, my software could have. I mean, I came at it different ways with that software. I really did, all ways, and it kept coming back with that. It kept showing that up with the pixelation technique and multiple softwares. I hit it in, that little monster kept showing up when I would move it around. So that monster would have to be an anomaly that each one of the softwares, different companies, not like Adobe only. It was different companies that I used, and they both showed this monster. I'm sorry, 3 companies I used. So they both showed that monster coming out, which presents as rebar, which I have as, I believe, if we're going to consider it rebar, that would be here. I don't have it being that high in here, having this fracturing there and then showing. I don't have that, but I have it possibly the BMA, which she might have had line of sight of. That was tugged on, rotated, dropped down, and then we get the spider showing up. End of video. Take care. Love you all. Don't quote me on any of this stuff too much. We're still working it out. The details still got to be refined. I just wanted to give you a bunch more data to work on because you guys, frankly, I wasn't going to give any more data. I was just going to listen, just be patient for a while. But you guys, your messages about withdrawal and where's more content, and I keep coming back looking for your new videos. You guys forced me to make new videos with those comments. So, yeah, there's a lot of detail I can give you, a lot more that would data stack. That's just biasly supporting or reinforcing the same video I gave of this the first day with its minor details like these, and because this is not a proven. That's a proven. That sitting on the deck is a proven. This is a proven. It's on the deck. These cars are proven. The fractures are proven. The flower pot on the angles are proven. The consolidation of material on an angle are proven. The fracture, the control joint, proven. All of the puncturings, proven. The rolling of the planter box going down, proven. All right, this is all before they started doing demo work. All that's the proven stuff. All right, this is not a proven. This is a theory of what I think it might be, and coming from this BMA here. Take care. Oh, please like and subscribe. And all haters, please go away. Incidentally, this was going to be my family that came out, the running, but I never got around to introducing you to Mama Bear, son, and I need a little robe girl. But this one's terrible. Maybe from the other apartment next door, the wall fell down, and maybe we're looking at the wall, which would be block wall, and I don't get that as a debris like that. The block wall, they like to flip over. They don't really like to go, like, even if you push it from the bottom, it would be more of a drop down. It would be a flip over. I just don't get that. I have a video actually where I push over a brick wall, and that's interesting. But when you get to the bottom of it, when it crashes, it goes, splat. It goes into multiple places. It doesn't stay together, consolidated. But a reinforced slab would stay consolidated. So that's why I have the reinforced slab doing that. But how the hell do we get these things separated? Just for no reason. That slab, when you look at it, yeah, I know I should hang up, right? It's actually past this column a little bit. It's right over here, right thereabouts, so I think I can see the end of it. So, I mean, I'm reaching, but I'd have to go way over here for the continuation of the construction joint. But it's somewhere about here if you guys go dive back into the video contents. Goodbye.